So thank you for all the brave people who, after last night party, came for this first session this morning. I really appreciate. And I hope we'll have time for you to enjoy the presentation. So what are we doing at Autodesk about this new technology? So usually Autodesk is not really interested in developing application directly for devices like this, but we are interested to explore what we can do with this device for our customers. So we're trying to experiment how we can use our technology and deliver 3D content for different devices. So it's really about delivering innovation for design and business industry in our customers. So I divided the presentation in 3 categories, and I'll probably mix a couple of them while I'm talking. But when you work with a new display device like the Hololens, which I have here, or others, usually we are facing a problem with the user interaction with the application on the virtual world. So we need to also embrace new input interfaces or way of working with this interface. So working with the arms on the gestures could be very painful after a while, so you need to invent new way of interacting. And at the end, for us, it's really about delivering interactive 3D storytelling to people because this is what our customers want at the end. So here is an example of what we're trying to do. So Pier 9 is our let's say, innovation center in San Francisco. On one area into this office is we have a CNC workshop. So we have CNC machines. And for example, we did equip these CNC machines with sensors which are emitting data all day long. So we can collect information about the usage of this CNC machine, and we can aggregate the information to do something with it. On the right side bottom, you have a web browser running the digital model of this office. And we can display the data into your web browser in a 3D context. While if you use tablets like the Tango tablet, for example, you can do feature recognition directly on site. And you can match the real world with the digital world. And this is how you can probably interact with the real world from your digital world. So that was probably the first experiment we did 2 years ago. So to come back on input devices, I did try to list all of them, and I know I already forgot 2 or 3. The natural way to work for us today on computer is keyboard and mouse. But when you go and use this kind of device, depending if you're on VR or AR, you may need to use something different. So remember that in a VR context, you fully immerse into the virtual world. Unless you know how to use your keyboard without looking at it, you can't use it anymore. You need to interact directly into the virtual scene. You can use probably a gamepad if you want to, but your outside experience is pretty limited. Whereas when you use IR device like this one, you have much more opportunities to interact with the real world. So you can still use your keyboard, you can use other things. So my message to you is whenever you design an application or whenever you want to write an application for devices like these ones, you need to invent the way you want to drive your user through the experience. And there's multiple ways to do it. You can create menus, you can use external devices, but you need to create the experience for the user so the experience is very smooth through the storytelling. And there are multiple things you can do. So let's look what we did, for example, with the Google Tango. So here, my colleague Hans in the San Francisco office, he's just doing geolocalization within the building. So he's matching the digital 2D model with what you see on the tablet. So while he walks through the office, he can recognize where he is into the digital model. So that's 2D, pretty simple. If I go a bit further into the video, it's going to switch to 3D somewhere along here. Where is it? Yeah, here. So now with the level of details while he's scrolling out the things is going to go into a 3D mode where we here we see like the full block of the office, and this can still geolocalize himself into the building. Now doing directly the 3D on the device, it can still work through and match the real on the virtual world. So here there is no need of user interaction other than using what is coming from the tablet, so the different gyroscopes on feature recognition. So it's pretty simple, and it can just walk through and match its position into the building. Very simple. One thing you can do with that is now you can run simulation. So we're having our game engine, and now that while you feed the tablet with the camera and you match the building, we can recognize the different walls, floors, etc., and we can run that through a game engine, and we can flood water into the building, which is pretty cool. Now you like it swim inside indoor swimming pool, and you can get that done very easily. So before I go further into this presentation, I'm just curious, how many of you are developers? Couple on designers? Okay, it's half-half probably. So I'll try to just share what is interesting. So another experiment, so that is actually where it started from in our department. So if you are an architect, you design a house, and you want to sell the house to your customer. You know, you design it, and you want to sell it. If you, like my wife, you can't project yourself in 3D, you have no clue, except it looking from the outside, oh, it looks nice. How the house looks like, does it fit what you want? Would you live in it? If you're not, then what you can do is, again, you can use a device where you can have the 3D experience of visiting the virtual house while it's not yet built. And this is more interesting because this is what architects are interested by. So that was our first attempt of doing that experience. So here we're working into a corridor, and because we run that through a game engine, if we want to climb the stairs, it's possible, while there's no stairs into the real corridor. But you can do it, and then you can virtually visit the house before it's built, and you can make your comments. And you can have the experience of saying, yeah, that's something I'm willing to buy, so good work, guy, or remake your work. And you can interact with objects. We'll see later that you can interact with objects. So new display interface. On this is where it becomes interesting for me, because the tablet has been there for quite a long, but your hands are already used, so you can't really do anything with that except it maybe clicking on few things. But with a new display, whether it's the Vive or the HoloLens or the DAQRI helmet, that brings a lot of new experience to the customers. But before I go into that, two things I want to mention. Who heard about the F-35 jet fighter? Yeah? You know that this helmet has plenty of gadgets into it, including augmented reality. So these guys have very nice experience, but see at the bottom of the slide how much it costs. I don't think any of you are going to buy this one, right? $400,000 each. It's fun, but expensive. Nothing compared to the jet fighter itself, but yeah. On augmented reality for jet fighters is not new. You know, before they had a little screen on top of the cockpit. to drive them, but now it's embedded into the helmet. And they have plenty of very nice tools on it. But look at the date here, March 1st, 1993. There was a publication made by Autodesk that we did the first augmented virtual reality device back in 1994. And we were really proud of it. It looked like this one. You see, it was very well designed and smooth and light. No, it was super heavy. You needed, it was not expensive. You know, it was like in the range of $1,000, $2,000 each. And we're proud because you were capable of doing like a 4 frame per second with only like a box on a sphere. So, yeah. But, yeah, it was there. So you see it took like, let me count, like a bit more than 20 years to come to what we have now, which is a lot better. So just for the fun, this is what we have now. And I want to make the distinction between two categories, well, let's say 3 categories of device. You have virtual reality. Virtual reality is you fully inside the virtual world, okay? Even if people say you can still feed the real world with a camera, that's just a workaround, you know? The virtual reality is really to be inside a virtual world on shared experience. Where our AR device, I don't think there's any yet which are working great. We are more like in a mixed reality world, like the HoloLens and the Meta or the Dacry, they're more like mixed reality. So what is the difference between the two? Because it's important. Mixed reality is you project an hologram. And the hologram can be anywhere, like on this floor, floating in the air. Doesn't really matter. You bring a virtual object into your real space. Augmented reality has another meaning. If I'm looking at the ceiling, I would recognize the ceiling, and I can project an hologram of things which I'm not seeing, right? So, for example, if I have HVAC things on the ceiling here, I would see them because from the digital world, I would recognize they are here, and I can project them precisely at the position they are. This is what is augmented reality, really. You need positioning. And none of these devices, even though they kind of be able to do it, I hope there's no Microsoft guy in the room, they're not yet there, you know. If my experiment with this device is, if I'm scanning the floor here on this room, instead of getting one mesh for the floor and recognize this as a floor, I'll probably get like 10 mesh. And the mesh will not be all aligned. There will be some deviation. It's already good. I can already work with that. But this is what I mean, is that before I recognize this is a floor, and this floor has some electrical cable or whatsoever, I still have to do a lot of work. So my colleague, Keen, last year was very proud to test the Dacry helmet, if you have heard about it. He was in Geneva, and he sent me that photo, and I immediately replied with this one, which is, yeah, nice, but you're not the first. Anyway, the Dacry is also another thing that we're going to try. But before we go into more details about this, when we started in our team to work with virtual reality, augmented reality, we work with Google Cardboards. And you can design your own cardboard on using your phone. You can have a very good experience already. So that's one experience we did. Like, we designed it our own. We 3D printed the glasses, and then we stick it to the phone. And this is how it looks on your phone. It's like using WebGL on WebVR. We can publish a 3D model directly on your phone, and then you can play it directly. So since you already bought your phone, no more expense than like probably $20 to have the Google Cardboard, and you can already have a very good experience. So that's something I would encourage you to try. But for us at Autodesk, it's really about 3D storytelling experience for our customers. So for that, I'll just go very quick. We're using our own game engine, which is Stingray. It's more or less like Unity. I'll just play one video so you have the feeling how it looks like. So it's pretty good in terms of game engine, but nothing different from Unity. So if you're familiar with Unity, you'll get the same thing. But what you need to work in this area is that your game engine should support the different devices. And because we have the source code of our game engine, we can support almost all the VR device. So we go from the HTC Vive to HoloLens, Morpheus, on more. And we also provide, we call that VR template, which is like the basics for doing navigation. So when you work into a virtual world coming from 3D assets that you design, like, let's say this building, you can't really walk into the building long distance because you limit it always to a little square, like 5 meter by 5 meter. So what we do here is that we provide teleporting. So you just point where you want to go, and you teleport yourself into the virtual world. And we provide automatically things like you can interact with objects. So as long objects in your design CAD file were specified with certain properties, they will immediately be interactable with you. Autodesk Live is actually the first product, so that's the only marketing speech I'm going to do with you, is actually the only product that came live after all this research, which is really about publishing a Revit model to a virtual experience using devices. So we do that on the cloud fully automatically, and then you'll get all these interactions set up for you directly. What we're experimenting as well is simulation. So in this case, an old platform, you have a fire, how do you escape? How people escape that platform? So we can run the simulation on, you can be part of it, so you can be in the virtual world, and all these yellow pylons are actually people trying to escape after a while. So you can run the simulation, and you can watch it like if you're a supervisor of the old platform and do the simulation and get the result. So that's what you can do with a game engine, and this is what we're trying to experiment for our customers. So as I said, the only thing you have to do is just to export to our cloud service and make it. So I mentioned menu. So when you're in the virtual world, this is what kind of menu I was talking about. You could have like image menu, and you select one experience you want to have. That's one way to do it. If you're in the AR, mixed reality world, you can use tablets on other things. But I'm always impressed by this one. The video is quite long, so I'll just go quickly through it. I'm just explaining what we did here. So we used drones to take photos of a very big terrain. And from these photos, we rebuilt the 3D mesh of that terrain. And we imported it directly into the I can't turn it off. So into the HTC Vive. And here we always have the same interaction where you can teleport yourself to visit the terrain and see what's going on. So you see that the resolution of the mesh after doing reality capture is pretty good. So all the hotspot here is a different place where you can teleport. I think we also have somewhere in the air some balloons where you can be in the air and watch it. So yeah, so you can see from the above the terrain which was captured. If you're not like high sick, I don't know how you say in English where you're sick when you're too high. You can have that experience too. Okay. The last thing is automotive industry. So here, it's very different because people are less interested by the experience itself, but they want very high quality rendering as well as very fine, detailed surfaces. So they can design the car that you're going to buy. So we have a team, I think they're based in Germany. They really work with different companies like Ford, GE, etc. And they work to make that experience for them very good. And this is where we start collaboration. Because until now, everything I said was kind of one person running the experience. When you start with the automotive industry, it's all about collaboration. So what means collaboration? Collaboration means that you're sharing the same data set. And if you modify or you point to a specific item into the experience, you want to share what you're doing with everyone being in the party. And this is what is interesting because this is what you're doing at work every day. So why not bringing that into the VR experiment? And then we have tools to create different things. So here are the industries. So I have video for each, but I'm not going to play each of them. But this is like industry-specific solutions or research we're doing. So interactive design, where you put elements in different places in the room so you can do the interior design. Same thing for the outside. On here, on this one, we're just putting trees around. So if you want to make your garden, then you can see how it will look like. So you select into the menu what kind of tree you want to put there, and then you create instances and you position them. So that, just for fun. Medical research or molecule viewing. This is actually the HIV virus. So here what we're doing is when you're doing research, professors, they're interested to know how the molecule looks like because they never see it like at the scale of human, you know. They only see it like photos on microscope. But here they can do the experience directly like in a VR world, and they can navigate inside the molecule. So when we were running that with one of the professors went inside the molecule and just realized there was a hole into it. So it was very funny to see the guy discovering something he never figured out through the microscope, that there was a hole inside. For sure, we can explode things, and we can do other things, so like coloring different, not molecule, but proteins, so you can figure out how the protein looks like. So very helpful for doing research. I heard another story yesterday from someone from the Microsoft team where using an external rendering device, they were able to create surgery experience for students. So they were overlaying a body with what they had to do. So they were like teaching people with very high quality. So that's another thing you can do. User interface, I'll go through. Sketching. So let me play that while I'm talking. So sketching, personally, I'm not very fan of that. At SIGGRAPH, Los Angeles, last August, someone came with a Maya plugin for doing 3D modeling. It's fine, but I don't feel we get there. The interaction is not natural enough or not precise enough. So if you're in the game industry, creating a monster, it's probably fine because you don't need to be precise. But if you like an architect or a mechanical engineer, you're working with like a millimeter. On these devices are not yet there to work at this level of precision. So for drafting on conceptual, that's fine. But for doing something more advanced, I think we still need to do more research. Already shows that about architects, so I'm not going to show that again. So let's come to the core of the problem now, model preparation. Most of the time, for things I've been showing there, and I'm going to show you now, you will spend more time bringing your 3D asset onto your device than anything else. For sure, if you just want to do like a draft 3D model, etc., you can always import something using FBX or other technology. But that's just conceptual. If you want to really create an application which works with 3D data or 3D assets, you will always face this problem, which is, how do I bring the information onto the device, let's say automatically, or the less painful possible? Because each device supports different number of polygons, how many textures you can support for having a good experience. So what I was showing at the beginning with the WebGL was to use our Forge viewer, which enables WebGL. Let me explain what Forge is about very quickly. So Forge is a technology from Autodesk which can convert any 2D and 3D file format to JSON. So you take SolidWorks from our competitor, or Inventor, or Revit, or Maya, Max, whatsoever. You convert that to JSON. And once it's in JSON format, you can consume that information using API, REST API. And then you have all the information about the geometry, metadata, material, and hierarchical information. So hierarchical information is very important when you work in the industry, so you know that a door is on a wall is on a specific floor, and all this information will be available. So this is what Forge is doing. So this is what I'm going to use for the rest of the presentation. And the viewer is just one way to consume that information. So if you use your phone, you can have this VR experience immediately without programming anything. So one of my colleagues wrote the Rocket website where you publish a 3D model, and then you can start a collaboration tool with your phone. So one person being on a computer doing things, and everyone sharing the experience on his own phone. So because I'm not on internet, I can't really show it now, but I can show it after the presentation if you're interested. And then what we're going to do now is, so I can't talk and do the presentation at the same time. So is there anyone who wants to volunteer to come and help me on wear this device? Someone? Yeah, just come. I'll just start it for you. And yeah, thank you. So you'll probably need to stay around here. And we'll see if I just did something wrong. Yeah. Let me remove this. Yeah, starting. Okay. So, and what I'm going to do, so we can share the experience, is I'm going to connect to the device through my browser and start this. And what you see on screen is actually what this guy is seeing on the device. So we do overlay the hologram on the real world. So there is maybe a 1-2 seconds delay between what it does and what you see. So if you say smaller, hello,
hey.
Can you say smaller?
Smaller.
On watch?
Bigger.
Yeah. Oh, cute. Yeah. And now make it very big. So say like 2-3 times bigger.
2-3 times bigger.
No, bigger.
Bigger.
And then, yeah, it became, ooh, what a monster. Okay, so what is nice with the HoloLens now is we can, because HoloLens has this special recognition stuff, you can start sharing experiences. So if you had an HoloLens and we can connect the two HoloLens together and you can interact with the same model together. So make it a bit smaller, please. Something reasonable.
Smaller.
Yeah. One more time, maybe? No, it's okay. Say play. Again?
Play.
Oh, and so maybe you can click on one of the joints. So you know how to do the click? Like, yeah, exactly. So now you can interact with the model. And when you click on joints, then you start animating the robot. And if someone had a second HoloLens connected to the same scene, they could both interact on the scene. This is what we call collaboration, because now they can talk as well. So the HoloLens has microphone, and they can discuss between HoloLens. So you would be like in the same office, in different space, or in the same office, same space, and you can share the experience. Okay? So, can you do the flower sign? Like this? No? Okay. Yeah. So kill the window. You see there's a white window. Here. Yeah, here. Kill it. There is like a close. Yeah. Redo the sign flower. Like this. Yeah, it's here. And click on Unity 5, UI Test 5. This one, perfect. The black one. Yeah, click again. So on this experience now, it's a bit different. What we're doing is that we're taking a mechanical piece and we bring it into the real world. And it's done fully automatically this time, which is like there's no user interaction, no artist coming to make the things nice, because on the previous one, actually, Keen, who did this demo, spent like a week with an artist in Sweden to have this model working nicely on, the rendering, the lighting, and etc. Where here, we're just taking the model out of a CAD package directly, and we just import it. And it still looks nice. And we still have like the smaller, bigger commands to do things. But I added a couple of other things. So you see there is like a tooltip when he's moving the cursor on object. So the tooltips are actually metadata from the original CAD model, brought onto the HoloLens. So here I'm just showing one into a tooltip, but really you can show anything. So I'm still developing the application where you can say, show me properties from what material it is, what is a manufacturer, so you can ask different kind of things. But I have a nice command which is explode. Yeah. So now because I have this hierarchical information at my disposal, I can use this information to do very different things. So maybe you can point to one thing not red, and you say select. Again? Yeah. And you see now there is a red wireframe around the object. So you can interact with the object. So imagine you have a big mechanical, like a car, and you want to see the engine. You can select an element, say hide. You can remove it. You can see the engine. You can select item on the engine, show me properties. And you can share this experience with someone else, and you can discuss what change you need to do to make the experience working. So maybe you look at me now, and you say menu. You should see two images. Yeah, point to the house and say load. And do you see a house? Okay, so maybe I need to restart. Stop. Yeah, sorry for that. Sometimes, yeah, sometimes the HoloLens is having problems. So same command, bigger, smaller, explode, anything you want. If you make the house big enough, you can do a virtual visit of the house. Yeah, on your inside now. So in the kitchen, and you can still interact with objects. This is a very nice thing of this mixed reality things. You know, I'm not yet at the higher level. Okay, so it bugged again. It's not really important. You got the idea. Yeah. So if you want to try that yourself, we have another HoloLens as well on our booth. So you're welcome to come and try. And thank you very much for helping. Yeah. Thank you.
Thanks a lot.
So that's what I wanted. I already said that. It's just like this is the pipeline to get the things done with HoloLens in this project, which is you post a file, you export it to something, and that you get the hierarchy, properties, and derivative. What we call derivative is geometry on material. Do you have any questions? Yes?
Could you just clarify the difference between augmented reality and mixed reality? I'm not sure I understood it.
Yeah. So the question was, can I re-explain the difference between mixed reality and augmented reality? Mixed reality is what I showed here, bringing a house as an hologram into this room. An augmented reality would be seeing what is behind the ceiling to match the digital model on the real model. So if there is electrical cable here, and they are on my digital model, I should match these with the one which are real. So I can overlay the ceiling with additional information. So there is a match between real and virtual. Whereas I'm putting a house here, there's no house. So it's more like mixed reality because I just project an hologram, period.
So you would have to actually know the elements in the room then?
Correct.
Okay, and then add on to them and then just project all of it.
Absolutely. And that means I would need to know where I am and do feature recognition. So knowing that this is a ceiling. Okay? There was another question here. Yeah.
The collaboration that's occurring, is that a feature between the two HoloLenses, or is that proprietary to Autodesk?
So the question was the collaboration service, is it coming from Autodesk or from Microsoft? So actually you can do both. So, sorry. The HoloLens has a collaboration service implemented directly. So you can use that. And it has a notion of space. So whenever you can connect spaces together, then you can collaborate. And the HoloLens which are connected together would exchange the information. So whenever someone does something, it reflects on the other one. So it's built in. You can build your own. It's quite easy to do. You can use Socket.io with just one server, and you can send the information you want. So you can do both. There's nothing Autodesk specific here, absolutely. Any other question?
Yeah, back here. I'll just start out. I'm curious, in the work that you're doing, there's a few things where your reference are just not quite there yet. I'm curious if the main limitations that you're seeing right now are in terms of the hardware and the platforms, or are they just in terms of our understanding of the user experience and how you use the hardware platform?
Yeah. So how can I rephrase that question? For the recording, because FATC is recording this presentation. So the limitation which were shown into the different demos, are they hardware limitation, software limitation, or we still need to do research to make that happen? So I would say it's a bit of everything. Today, the HoloLens is probably, in my opinion, on that just engage myself, is probably the best device I've used up to now, because they probably make add use of the Kinect experience, and they added special recognition as well as the collaborative engine, and they have sound, they have voice recognition. So on the hologram stabilization is very good. So to be honest, for me, it was very good. But I think it's not yet there. They will need to make another version which is more powerful, so you can render more on the device itself, and probably work on the internal software, so the programming is a bit easier. In terms of user experience, I'll just repeat what I said before. I think you need to design the user experience for the app you're developing, and you would probably need to decide what are the input device you want to use and how you want to use them. And today, I think we don't have the tools to create, let's say, a uniform user interface platform. So it's more like, for me, it's more like hacking today. So this is where we are today, I think. But Autodesk, we just formed a team, a division, I would say, 2 months ago, where they're doing this kind of research, because, as I explained, for our customers, we need to deliver tools for them to publish what they create with our desktop software. I hope I answers the question. Yeah. So, what the question was, am I using Unity?
No, the question is, what's the significance of Unity or game engines with VR?
Oh, okay. What's the significance of using a game engine for VR? It just makes the programming a lot easier. The HoloLens, you can do direct 3D programming in C++, and you'll get better performance, and it would be as equal as a game engine, but a lot more complex. You would need to create the vertex buffer, you would need to create your textures, your rendering pipeline, etc. Whereas in a game engine, you just focus on delivering the experience, because the game engine will do everything for you. You would need a sphere, you create a sphere. Create sphere, period. In direct 3D, okay, how many triangles I want on my sphere, I decretize my sphere, etc., etc. Just makes things easier. Maybe the last question? Yeah? Thank you.
Have you used Euphoria?
Sorry.
Have you used Euphoria, the image recognition library, to bridge the gap between mixed reality and AR?
So did I use Euphoria for doing feature recognition? I'm just starting, yes. But it can't really run on this device because it's not powerful enough. So what I'm doing right now is I'm trying to use my Mac, connect it with the the HoloLens on all the math happens here. So it's more like research for now.
They have a library just for the HoloLens.
Yeah, but it's not fast enough. I mean, if you want to do big model like we do, so you have like thousands of triangles and you project that with metadata and etc., and then you try to do feature recognition at the same time, the device just die. So what we do, what I'm trying to do now is I fill the computer which does the math for feature recognition and just sends light data back to the HoloLens. But yeah. So thank you very much. I don't want to oversee. If you have any other question, I'll stick around here, and if you want to try the different experience we made, you're welcome to come to us. Thank you very much.